David Andersson på Ecoera AB.
Tack så mycket.
Varsågod.
Okej, tack så mycket. Tack till Sustainable Business Hub och till ESS. Och tack även till molekylär biofysik där jag pluggade för 10 år sedan. För nu hade jag möjlighet att förklara vad spallation var för någonting. Vilket var bra. Are we any English speaking in the audience at the moment? One, all right. Keep this in English. Thank you. I will show you how to, if you remember the turning torso tower, which Colin showed you before, I'm going to show you how to be able to remove that amount of CO2 from the atmosphere, and with some positive side effects as well. My name is David Andersson, and I'm CEO of the company, started from Chalmers University of Technology in 2007, Ecoera. And I'm going to talk about carbon footprint of the ESS facilities. Any facility will always have a carbon footprint, no matter how much you reduce the emissions. It will also, any facility will also have an impact on ecosystem services, which will be lost during build-up. And in the case of this facility, you will have a CO2 footprint. You will also take agricultural land into other types of use. So, you want to create a truly carbon neutral facility. And this is to balance out the effects. So what is carbon negative then? To remove the CO2 from there, what is that? Well, you have carbon positive systems, that are fossil fuels, of course. You have carbon neutral or almost carbon neutral systems like wind, hydrothermal, hydropower, geothermal, nuclear, etc. And then you have carbon negative systems where you actually remove CO2 from the air while creating a renewable energy source. This is where we operate. So, this is how our platform works. We call it the biosphere platform, and we use an old proven technology. Photosynthesis has been around for a couple of billions of years, and we capture carbon in the form of crop residues. We use biomass waste from agriculture, which we condense and transform into pelletized amount, which is then going through a process called pyrolysis. And this process generates not only a bioenergy source, it also generates a stable form of carbon called biochar. And here is some of this. You can please send it around. This is condensed atmospheric carbon, solid form. You can even eat it if you want, but please send it along first. And this we deploy into agricultural soils. And this has some nice side effects. What happens is that we geotag this, and we have a traceability from carbon dioxide in the air down into the soil. But what happens with the soil? Well, we have seen a harvest increase when we add our biochar to agricultural soils in southern Sweden. By 33% we had an increase of the crop yield from barley. And this is a way to balance out the loss of agricultural land used for any facility, and in this case for the ESS facilities. And the good thing is that it is also a stable form of carbon. It is a carbon sink, and it has a residence time in soil for over a millennia. It serves as a dynamic sponge in the soil to actually produce better nutrient uptake for the plants. And down in beautiful Österlen, we have a facility called the BioAgro facility, which is producing the substrate for this at 3 tons per hour. We also have this offer to create a carbon sink for the ESS facility to balance out the actual carbon footprint and the emissions yearly. And in addition to this, regenerate the loss of ecosystem services from the soil. And this is an image from, I've grown up on a farm actually, so this is from our own farm that's using this at the moment. And this is a way to remove the CO2 from the air and make it truly carbon neutral. So the conclusions are: the carbon footprint of the ESS can be removed, the land loss can be regenerated, you have a bioenergy source in this process, you have also cost-efficient carbon capture, and you also have a team ready to implement in the form of our company. And here's our contact details, and we have some more paper material with some extra information for anyone interested. Thank you very much.
David Andersson, några frågor? Vad är baksidan?
Den största baksidan, the biggest downside with this is that we can't really find any downsides. Okay. Actually, that's our biggest challenge. Actually, this is an old technique used by the Amazonian Indians in the Amazon rainforest. They actually use this technique to enhance their soils, to be able to use rainforest land for a better crop output. And so far, these soils that they produced, it's still, the carbon in it is still stable. And we haven't seen any actual downsides with that.
I don't quite understand how you get around releasing CO2 into the atmosphere when you do the burning. Can you chemically explain what is happening?
Yes. You're also free to ask Folke Ginter, our system ecologist, and also René afterwards, because I have to run off this presentation for another conference. But yes, what happens is that some of the carbon atoms in the biomass gets emitted as CO2 when we burn the syngas from the biomass. But half of the carbon atoms are fixated in the biochar form. So therefore you will have an emission of CO2, but that emission will be, of course, from a renewable source. That is
the carbon you don't burn, you don't get energy from. So I don't quite see how. There's something that doesn't add up for me, but we can take that.
Yes, the syngas is burned. So you lower the efficiency of the biomass, the energy efficiency of the biomass. Mm. And some of that carbon is used to fixate it.
Okay, I think I'll take that.
Yeah.
Yes, so that is the answer.
Tack så mycket.
Tack så mycket.